we'll be discussing about dynamic storage allocation problem. So in the previous lecture, we have seen how memory allocation is done. And I told you that there are a few things that we need to keep in mind while allocating the particular free partitions to the processes. So that is what we are going to discuss here, the dynamic storage allocation problem. Now, what is this problem? So the problem is how to satisfy a request of size n from a list of free partitions or holes in the main memory. So we are having a request of size n. That means we are having a process which is having a size of n, and that size of n represents the amount of memory that the process is going to need for its execution. So for such a process, which is the partition or hole that we are going to assign from the main memory? So when we say hole or partition, it just means the fixed partition that we were having in the main memory that we discussed in the previous lecture. So the question is, which is the partition that we are going to assign for a particular process which has a particular amount of memory requirement? So as a solution to this problem, we are having three approaches. So the first one is called first fit, the second one is called best fit, and the third one is called worst fit. So we will be seeing the solutions or approaches one by one, and we will try to understand what it means and how are memory partitions allocated to different processes in these three different approaches. All right, so let's start with the first one. So the first one is first fit approach. So what happens in this first fit approach? So in this first fit, we allocate the first hole that is big enough. That means we will be just picking up a process from the input queue, and we will be seeing which is the first partition that we have which can accommodate this particular process. So we'll be just starting from the top of the main memory, and we will see the first partition that is big enough to hold this particular process. And then searching can start either at the beginning of the set of holes or where the previous first fit search ended. So when we are scanning for the holes or the partition, the scanning or the searching can start either at the beginning of the set, that means from the top of the main memory, and we can go down, or we can start at the place where the previous first fit search ended. So I will be explaining this further when we explain it with a diagram. So let us see what is the next point. We can stop searching as soon as we find a free hole that is large enough. So as I said, when we see that we find a partition that is big enough to hold that particular process, we just end the search and we assign that particular partition to the process. All right, so let us just explain this using a diagram. So here I'm taking that same diagram from the previous lecture that we have taken. So here we have the main memory. It is divided into several partitions. So we have 1, 2, 3, 4, 5, 6 partitions, and we have 1, 2, 3, 4, 5 processes that are waiting in the ready queue or in the input queue. So in this first fit approach, what we are going to do is we are going to take a particular process and we are going to just start searching for the partitions from top to bottom, and we are going to see if this particular process can fit into any of the partition. So the first partition that we find which is large enough to accommodate this process will be the partition that will be assigned to this particular process. So for example, if we take this process and if we start scanning for the partitions from top, we see that we have this block of memory or this partition which can very well accommodate this process. So what will happen? This process will be allocated this particular partition over here. Okay, now coming to the second one. Now this process, now let us see where can this process fit. So we see that if you try to fit it here, it is not going to fit from the size. You can see that this memory location is smaller than this process. And also, if you look at the third one, it is smaller than the process, so it is not going to be able to fit here. Okay, now what about here? So here we see that this is big enough to hold this process. So we can easily accommodate this process in this partition over here. Now coming to this third process. Now for this third process, before we allocate any partition, let us read the second point again. So here it says, searching can start either at the beginning of the set of holes or where the previous first fit search ended. So when we are going to search for a partition for this particular process, we can either start searching from the top, that means from the beginning of the set. Now where is the beginning of the set? The beginning is here. This one is already occupied. Now this is the beginning. We can either start searching from here, or we can start from the place where the previous first fit search ended. Now, which is the place where the previous first fit search ended? It is here. So for the previous process, when we were searching for a partition, this was the partition that was found and this was the partition that it was allocated. So this was a place where the previous first fit search ended. So we can also start searching from here. So it is up to us. So let's say that we are going to start from the beginning of the set. So we are starting from the beginning here again. Now if you start from the beginning, this is occupied. This is the next free one that we have. Can this process be accommodated in this free one? Yes, definitely it can be. So we accommodate this process into this partition over here. Now let's see, let us take the fourth one. So the fourth one, if you check, it is not going to fit here. And what about here? Yes, it is going to fit in this location. So we can allocate this memory location for the fourth process. Now we see that we have the fifth process that is waiting here, and this fifth process cannot be allocated to any of the free partitions at the moment. Why? Because it is not going to fit. It is not going to fit here, nor is it going to fit over here. And we are not able to combine these two free partitions also. Why? Because I already told you in the previous lecture, we are able to combine them only if they are contiguous. So here they are not contiguous, they are not adjacent to each other. So we cannot simply combine these two memory partitions. So this process is going to have to wait in this ready queue until and unless this particular process maybe finishes its execution, because this is the only partition where it can fit. So this is what happens in the first fit approach when we try to allocate memory partitions to processes using the first fit approach. All right, now let's go to the second one, which is best fit approach. Now in this best fit approach, let's see what happens. We allocate the smallest hole that is big enough. So in this best fit approach, we will be picking up a process and we will be allocating the memory location to that process, which is the smallest memory location, but it is big enough to hold that particular process. So we follow this in order to not waste the memory that we have. So here we must search the entire list unless the list is ordered by size. So in the previous one, we saw that we were just scanning from top to bottom, and whichever we found is fitting, we just put it there. But in this one, we need to search the entire list from top to bottom unless the list is already sorted by size. So we have to search it from top to bottom, and we have to find out which is the best fit for a particular process. So this strategy produces the smallest leftover hole. Okay, so let us take the diagram and try to explain this again. So here we take the same diagram, the same example that we took in the previous case. We are having this main memory with these partitions and these processes waiting in ready queue. So now let us pick up the first process and see. So we pick up this first process and we scan the entire list. That means this entire main memory we have to scan to find the partition that is the smallest one that can hold this particular process. So if you see here, this process can definitely fit in this, but this is not the smallest one. So what about this? Yes, this process can fit even into this partition here. And also if you see this, it is not going to be able to fit in this third partition. And what about this? It is going to fit here for sure, but this is too big. And also for this last two partitions, they are definitely going to be able to hold this process, but we see that the smallest partition which can hold this process is this second partition over here. So we will allocate this process to this second partition over here, which is the best fit for this particular process. All right, now let's come to the second process. Now for the second process also, if we see in the similar way, we can find that this partition over here, this is the smallest one which can accommodate this particular process. So we will allocate this memory location to this process over here so that it fits somehow perfectly into this. And now what about this third process? From the diagram, it is very easy. We can see that this process can easily fit into this smallest partition, which is this one. So it is allocated this partition here. And what about this one? It can easily fit into the smallest partition which is available, which is this partition over here, which can easily accommodate that. So this partition is assigned for that process. And we have this remaining big process, and this big process can be easily accommodated in this big partition that we have over here. So it is also accommodated here. And we see that all the processes which were waiting in the ready queue are given some partition or the other. And we see that they are perfectly, or at least they are close to perfect in fitting to these memory partitions that we have. And there is only one partition that is left empty. This is the only free partition or the hole that we have. So it says here the strategy produces the smallest leftover hole. So this is what happens in the best fit approach. All right, so we see that we are actually minimizing the wastage of memory if we are using this best fit approach. All right, now let us go to the last approach. So the last approach that we have is the worst fit approach. Now what happens here? In worst fit, we allocate the largest hole. So from the name itself, it says it is a worst fit. So what we are going to do, we will just take the process and we will see which is the biggest partition that we have, which is free. And then we will just be allocating that process to that biggest free partition. So we must search the entire list unless it is sorted by size. So just like the previous case, here also we have to search the entire list unless the list is sorted by size in order to find out which is the largest partition or the largest hole that we have. And this strategy produces the largest leftover hole. Okay, so let's explain this also using the same example, using the same diagram. So yes, we have the same example over here again with our main memory and partitions and the processes waiting in ready queue. So let's take the first process here. We take this process and what do we have to do? We have to allocate it to the largest hole. Now, which is the largest hole in our partitions? It is this one. So we will take this process and we will allocate it to this largest partition over here. Okay. Now, what is the next one? This is the next process that we have. So which is the largest hole that we have now? This is already occupied. So the next largest hole that we have is this one right here. So we will put this process into this hole now. Okay. Now, what is the next one? The next is this process here. And what is the largest hole that we have? So this looks like the largest hole. We will put this process into this hole over here. And also for this process, what is the largest hole that is available now? This is the largest hole that is available. We put it there. And what about this process? We are not able to allocate a memory location to this process now because there are no free holes that is big enough to hold this particular process. So it will have to wait until some or the other processes freeze their memory location and it may get a chance to execute. Okay, so this is what happens in the worst fit. So from this illustration itself, you must have got an idea that best fit and first fit, they are definitely better than the worst fit that we have discussed in terms of storage utilization. But if we are trying to compare best fit and first fit, it has shown in simulations that in some cases, best fit is better, while in some cases, first fit is better. So we cannot say for sure which is better, first fit or best fit in case of storage utilization, because it depends upon system to system, and also there are many other factors that affect it. But in case of speed, first fit is faster than best fit. And why is that? From what we explained, I hope you already have understood that, because we are just allocating the first available partition that is large enough to accommodate that particular process. So it is faster. All right, so these are the three approaches that we have for allocating memory partitions to particular processes. So I hope this lecture was clear to you. Thank you for watching and see you.